In the summer of 2013, an expedition set out to the remote coastline of East and West Greenland. The flight expedition was due to a recent discovery of aerial photographs of the Greenland glaciers dating 80 years back, which had emerged from the archives. The scientists now had the possibility to see with their own eyes how much of the glaciers had retreated since 1932. This could provide unique evidence of the effects of climate change. But to make it happen, they had to fly to the same locations and take photographs from the exact same height and position as they were 80 years ago.
In the summer of 2013, we were a group of scientists from the Natural History Museum of Denmark and from Aarhus University who traveled to Greenland. And with us we had a bunch of very old photographs. These were photographs that were recorded from the air of glaciers. This was really exciting because these photographs were the first that were recorded in the air and of glaciers in Greenland.
A little more than 80 years ago, in 1932, Denmark began mapping Greenland's coastline. This was due to a dispute with Norway regarding sovereignty over East Greenland.
At that time, East Greenland was practically a no man's land. And both Denmark and Norway decided to make really big expeditions in the area. They brought big ships with lots of people on board, and they brought airplanes and land parties. And both Denmark and Norway decided to make big mapping missions of the land from the air.
On April the 5th, 1932, the International Court in The Hague decided in Denmark's favour. Norway's action was declared illegal, and Denmark was awarded full sovereignty over all Greenland. The massive Danish research initiative became the starting point for new modern forms of expedition. This revolutionized the mapping of Greenland and gave Denmark a place at the forefront of international scientific power in the Arctic.
Before the 1930s, the land had been mapped by explorers. The most famous being Knud Rasmussen, who took dog sledges around the coast of Greenland and also across the ice sheet, where he mapped the land from the dog sledges. Now there was a new way of mapping. Instead of using the dog sledges, they would go up with big ships and lots of parties on land. And also they had the airplanes that they could use to photograph from the air. Now one expedition could take several years to complete.
But the expedition of 2013 had only 4 days. The ambitious plan was to take off in Kulusuk in southeast Greenland, fly to Semelik Fjord, and then north to Kangerlussuaq Glacier, and then even further north along the Glosseville coast, crossing Scoresbysund, and then further on to Constable Point. From there they had to cross Jameson Land to Stauning Alps, then heading back to Kulusuk to refuel to be able to cross the inland ice to Nuuk, and on northwards to Sugarloaf, then fly to Narsarsuaq, and finally back to end the journey in Kulusuk. It all depended on extremely good weather conditions in an area known for its harsh environment.
They took pictures to map the land, but doing that they also took a lot of pictures of the glaciers. And these glaciers were photographed in the 30s, and that is extremely important to us. Right now we have a pretty good idea of what's happening with the ice and with the glaciers. And we have a good idea of what has happened in the last couple of decades. But beyond that, we really don't know very much. And that's why these pictures are extremely important, because they can tell us what has happened to the ice during the last 80 years.
In 1932, the SS Gustav Holm disembarks from Copenhagen on a long 3-week hazardous journey from Copenhagen to Greenland. The ship encountered very rough seas on the voyage. Finally, on arriving in Greenland, the Heinkel is unloaded. The aircraft is fueled manually and the engine is cranked up, ready for some trial runs. And we see aerial shots from the aeroplane. It is remarkable to have live footage from the Heinkel. Prior to the 1930s, the hydroplane had been regarded too dangerous to use in the Arctic. But in 1932, using them was considered possible. The Heinkel aircraft has 3 seats in the open cockpit. The pilot sat in front and the radio operator behind, and at the back, where a machine gunner originally would have sat, was the photographer with his equipment. The camera was placed in a movable frame at the base of the fuselage, so that it could be rotated in all directions. The Geodetic Institute carried out this work, and the institute became attached to large-scale Greenland expeditions after 1932. Knud Rasmussen's 7th Thule expedition, Lau Koch's 3-year expedition, and Einar Mikkelson's East Greenland expedition.
From the early 30s, there are 2 big expeditions. One was led by the geologist Lauke Koch. This was called the 3-year expedition, and he photographed the east coast and northeast coast of Greenland. The other expedition was led by the famous explorer Knud Rasmussen, and he photographed the southeast coast of Greenland. Then later in 1936 and 1937, the Geodetic Institute of Denmark, they continued the flights and photographed the southwest coast of Greenland. Our idea was to go up to Greenland and fly in the tailwind of these historic flights, and then take the exact same pictures from the same locations as they did in the 30s. We were looking at these old photographs and tried to determine how high they were flying and how high the pictures were recorded. Back then they had a lot of time to spend. One expedition was called the 3-year expedition. And they had plenty of time to wait for good weather. We, on the other hand, only had our plane for 4 days. We were crossing our fingers that we would have good weather for these 4 days. This summer in 2013, we brought the old photographs of the glaciers. With us, we also had the aerial photographer Hans Henrik Tholstrup, and he took a lot of really nice photographs. He photographed more than 30 glaciers from the exact same position and height. We're really surprised to see the glaciers in their present position. Even though we have a lot of recent information from satellites and so on, it's still very surprising to get up there and see the changes with your own eyes.
There were many photographs containing glaciers, and as we know, Greenland's glaciers are melting. We need a longer time perspective, and thanks to the photographs we can go back 80 years in time.
When we talk about glacier science, one of the biggest questions is, can we make a reliable model of how the ice sheet are going to react in the future? The reason we want to make these models is to see how fast sea level is going to rise. This has a huge impact on everybody living in the world. And when we know more about the ice sheet and how it's reacting, we can make better models.
The basement at Suez Land consists of almost 500 million year old limestone and sandstone and has experienced many glaciations. The glaciers at Suez Land are not connected to the Greenland Ice Sheet, and all of them terminate on land. Since 1933 there has been extensive melting, largely because the glacial fronts are located at low level. The large glacier in the valley has receded about 3 kilometers.
When warm currents reach the coast of Greenland, which they often do, it is the same warm Atlantic current that heats up northern Europe. This current also goes to Greenland as well, and along the way it reaches the east coast of Greenland. Once in a while this warm water can reach all the way into the fjords and hit the glacier front. And when that happens, the glacier can speed up. In a very short amount of time it can triple its speed or even go faster. And when that happens, the huge amounts of ice is released into the ocean.
The Helge Glacier is one of the largest in Greenland and the third fastest moving. It has been studied intensely by researchers after it greatly increased its rate of advance in 2003, resulting in a considerable loss of mass. Studies at Helge have shown that this huge calving glacier is extremely sensitive to the temperature of the seawater. Under normal circumstances, only cold seawater reaches the front of the Helge Glacier. But when warm Atlantic waters enter the fjord, it destabilizes the ice front and results in a large loss of mass from the glacier.
The Arctic has been stable for a while, but right now it's contributing to global sea level rise. But it's not only from the Arctic that the ice is lost, it's being lost from all over the world. In South America, in North America, in Asia and Europe, glaciers are losing mass due to rising temperatures. If all ice was lost in Greenland, it would contribute to a 7-meter global sea level rise.
Here is an illustration of the large glacier Jakobshavn Isbrae in Disco Bay, the fastest moving glacier in the Northern Hemisphere. The glacier loses mass by surface melting and by calving in the deep fjord. Water from the snow and ice that melt on the surface flows via streams to form lakes, while some of it reaches the floor of the glacier. When warm water from the Atlantic enters the fjord, red arrows show the rate of calving increases, resulting in very large loss of mass. There are few places along the coast of Greenland where the effects of melting are as clear as the Midgård Glacier. Its front has receded about 30 kilometers, and an entire fjord has been exposed. Standing at sea level by the new fjord and looking towards the mountains, you can see the trim lines at a height of 6,000 meters. The fjord is 4 kilometers wide, and it is 55 kilometers from the front of the glacier to the point in which the photograph was taken in the summer of 2013. This glacier has been continuously receding since the first photograph was taken in 1933, but the rate of melting has increased through recent decades.
After Scoresbysund, we had to put down the plane in Constable Point, which is a big airport. We spent the night there and were extremely lucky to wake up the next morning for another day of great sunshine. We crossed Jameson Land, which is really a unique place. It's sedimentary rock, and the colors are really astonishing. We saw it in the morning where the sunshine was low and the rocks looked like they were glowing with yellow and bright red colors. Since the last 15-20 years, we have experienced a temperature that has been increasing, and increasing particularly in the Arctic. The whole world has also seen an increase in temperature in this period. The climate has not been stable in the last 100 years. For example, in the 20s and 30s, the temperatures were increasing, and they were increasing faster than they are right now, but they didn't reach the same high temperatures as we have now. Before this, it was the end of the little ice age, so the ice sheet was growing and so were all the little glaciers. In the 20s and 30s, the temperatures were actually rising more rapidly than right now, but the temperatures now are warmer than in the 20s and 30s. We are really excited about this information that we can get from the old photos because we can use it as an analog to what's happening right now. The time span that we have measurements of the ice has been a time where the temperatures have been increasing steadily and also rapidly. That's why it's so interesting to go back in time and see how the ice has reacted to similar changes. There are examples of a lot of glaciers that are retreating, but there are also some that have been standing in the same position for all 80 years, and even a few that have advanced. But when we look at the entire coast of Greenland, the vast majority of the glaciers are retreating. What we see with this project is also that there was a really fast retreat from the 30s to the 40s.
Gunnar Seidenfaden, Lau Koch's chief of logistics, wrote, "The aeroplane, it lifts our artificial eye above the mountain tops. It allows us to see behind the mountain walls. It transports us to the inner part of the country and to the edge of the Greenland Ice Sheet." Modern mapping has been accomplished as a result of collaboration between the camera, the aeroplane, and the stereoplanograph in a highly complicated process. How different this is from the pencil sketches of the previous century, drawn with frozen fingers from cumbersome sextants of theodolites and slowly moving dog sledges. Knud Rasmussen, together with Charles Lindbergh and his wife, who had just landed at Ammassalik in his Lockheed Sirius. Charles Lindbergh was on his way from the USA to Europe for Pan American Airways. Lindbergh also visited Lau Koch further north and was full of admiration for the work being done by Danish airmen in this tough, demanding area. In a single year, the glaciers have significantly retreated due to melting. We have been seeing a lot of headlines in the media. An enormous chunk of ice breaking away from the ice sheet, with all the water flowing from the ocean into the melting glaciers, is making the sea level rise. This process has been accelerating over the past 10 years. Flying in the open aircraft at an altitude up to 4,300 meters and with temperatures down to minus 40 degrees Celsius was something of a trial for the crew. Between 1932 and the outbreak of World War II, a massive 10 to 11,000 photographs were taken. After this, conditions became too hazardous for the expeditions. However, after the war, the expeditions resumed, with the participation from, among others, the Americans. Many of the smaller glaciers that terminate on land have disappeared over much of Greenland during the last decades. They advanced during the Little Ice Age and reached a size they simply were not able to maintain. This can clearly be seen with small glaciers where the retreat of a few hundred meters can result in halving their mass. This example from southern Greenland shows glaciers that are retreating rapidly.
It becomes much more real, and I think that this is an important product of this trip, to give people an idea of what has happened in Greenland over the last 80 years. What we wanted was to make a book that shows the difference of these glaciers from the 1930s and up until now in 2013. Then people can see with their own eyes how things are looking. So these pictures give a really important fingerprint on how the glaciers have retreated. To make a prediction on how the sea level rise is going to be in the future, we have to know how the entire system is working. And we have a very good idea about how the system is working, but our problem is that the period that we have observations is really short. We want to go back in time and expand this period so that our observations are becoming more reliable. And when the observations are more reliable, our models will be better, and then we can have a much better prediction on how things are going to be in the future. And then the error bars will be smaller. And that's the work that we are doing that will help people understand how the glaciers are reacting to climate changes. What we can see now is within the last 10-15 years, there's been a huge amount of ice released from the Greenland ice sheet into the oceans. The difference between these two periods with regard to temperature is that it's actually warmer now than it was in the 20s and 30s. In the 20s and 30s, all of the glaciers in Greenland were retreating. The little ones, the small glaciers and ice caps surrounding the big ice sheets, they were actually retreating faster than they are right now. But right now, the big and important glaciers, these are the marine terminating glaciers from the big ice sheet, they are retreating much faster than they were in the 30s. These glaciers, they are really important because they flow like a big river of ice into the oceans. And when the glacier hits the ocean, it breaks off and there's a calving. And this we see in the television, it looks very dramatic, but it's actually very normal, and this is what happens when the glacier reaches the ocean. But right now, with the climate change, it's happening a lot faster. So one big question is if this climate change is natural or if it's man-made. When you look at it from a glacier's perspective, it doesn't matter if it's one or the other. When it becomes warmer, the glaciers are going to melt more unless there's more snow falling. And right now, it seems like there's more snow melting than falling.
There can be little doubt that the melting of Greenland's ice sheet will have major consequences for all of us. If the entire ice sheet melts, sea levels will rise 7 meters. But even a rise of 25 centimeters or 1 meter will greatly influence how we can use our coastlines in the future.